The power that you already have being raised to a new power requires you to multiply. And that's what example 1 and 2 in a nutshell do. Okay? That's what example 1 and example 2 do for you. Where it gets a little tricky is example 3. Okay? Example 3 does look a little bit tricky, and I'm not doing there, I'm doing my book, or I'm not doing the book one. You can look at those, but here's example 3 for you. Negative b to the 4th power, whatever that result is, raised to the 5th power. Take care of the inside first. Okay? The inside is negative b times negative b times negative b, negative b. Since it's an even number of negatives, the result is a positive. Positive b to the 4th, to be exact. But we still have to raise that mess to the 5th power. Now I can write b to the 4th 5 times, or I can just go ahead and multiply them as the rule says that we can. Inside, take this piece, raise it to the 4th power. That's this. Then take that result, raise it to the 5th power. The power of a power requires you to multiply the powers. Parentheses play a funny role in all this. You have to obey the parentheses. And in example 4, I'm going to show you how that might work. 2y to the 4th power versus 2y to the 4th power. This literally means 2y done 4 times. Two times 2 is 4, times 2 is 8, times 2 is 16. So 16, y to the 4th, right? But this means 2y. In this case, the 4 is only acting on what precedes it because there's no parentheses. The parentheses force the 4 to react with the 2 and the y. Whereas here the 4 can be lazy and only work with the y. Okay? I need you to be extremely diligent about looking for parentheses. If there is an exponent following parentheses, then the entire parenthesis unit gets affected by it. Whereas if there is an exponent following something, but no parentheses are involved, it has to be looked at from this perspective here. Okay, that's example 4. I wanted to make sure you had those 2 things to look at. That is my summary of what is called power of a power. The second half of this lesson, and it's not much longer, is I like to call power of a product, which I briefly messed with that here. This is technically a power of a product. So I'm going to talk about what a power of a product is. This is the product of 6 and x. That product is what is getting raised to the 3rd power. 6x times 6x times 6x, which is 216 x cubed. Like that previous page When there is parentheses involved, that means the whole thing within has to be affected by the power. The 6 literally got cubed, and the x literally got cubed. That's what happened right there. And they don't get any more weird. They just get maybe a little bit more difficult. They're not, there's nothing in here that's wacko. Watch out when there's negative and positive numbers. Those are easy mistakes to make. Here, I'll give you an example of what one of those might look like. Here's an example 5. Negative 4 mn raised to the 3rd power. Rather than me write negative 4 mn 3 times, I think about it almost like I'm distributing it, since it's parentheses. Negative 4 times negative 4 times negative 4 is negative 64. MMM, NNN. So you can think in terms of, in exponents, like you're distributing. If you want to think about it that way. Some kids like that thought. The negative 4 got cubed, the m was cubed, and the n was cubed. All 3 items sit under the parentheses, so they all need to be affected by the 3. They keep making you still evaluate stuff, and this is my last example for today. Evaluate if x is 2. The first one is going to be 3x cubed. The second one is 3x cubed. And the last one is 3 cubed x cubed. So here, the only thing that is being raised to the 3rd power is whatever x is. 3, 2, cubed. Did you get 24? 3 times 8? Did I lose anybody? Justice, are you good? What happened? In contrast, this one right here, 3 times 2 is going to get raised to the 3rd power, right? Because there's the x. 6 is going to get raised to the 3rd power. 216. And this one, 3 to the 3rd power, 3 times 3 times 3 is 27, right? 27. The 2 is what's getting cubed, which is an 8. 216 again. Cool. And notice why these are the same. Remember how I said we're distributing when we have parentheses? We're really distributing that exponent?
Adam Hoskus and J.C. Piker to the office, please.
All they did here is show that. 3 cubed, x cubed. So what they did here is the same thing as what we did here, only it was just written slightly differently. Okay, today you have